class, let's talk about particles. Particles are a tool for game design where you can make a whole lot of nice looking special effects that don't necessarily have a lot of resource demands. The idea behind them is that we can hide things behind particle explosions. We can represent some things better with the motion of particles and sprites and things rather than building it directly into a sprite or animation or using an entity itself. Sometimes just having something there for special effects is a nice little effect. You can do things like simulate rain, fog, fire, spatters from the blood effects or water splashes. All kinds of things can be done with particles. So let's talk about how we actually implement them. So what are they? They're cheap special effects. The idea behind them is that they are as resource kind as possible, where entities have behaviors that are unique. Oftentimes, calculations will be involved with those like collision detection, logic, pathfinding, all those heavyweight things that we want to have our intelligent agents of the system to have. But we don't always need that much firepower. Sometimes something simple is the better approach. So the idea behind particles is they are cheap effects. Back in the id Software days, they just called them temporary entities, although that's not really a good name for it either, in my opinion. Because they're not really entities. They don't interact. They're not acted upon. All entities are technically temporary. They live and they die. Each particle, though, will have a timed life. So these things, we generate them, they will live for a time, and then they will die. What's great about them is that once we specify what they look like, it's set it and forget it. So I give it its position in space. If I can move this guy without... I can give him its position in space, give it a direction to move in, and maybe even some gravity. If we want to have like a gravity effect on it, we can have some give it a color, give it maybe a color direction. We can have color acceleration as well, and then it goes about its life. Then it simulates what it's going to do, and then the acceleration takes place, and then it's out, and then at some point it expires, and then it goes away to be recycled by the rest of the next thing it needs for it. Particles can be represented by simple pixels or rectangles, more complicated sprites, or any kind of thing that we can draw with our system. Now, the more complicated the draw ask, the more work is going to be involved. So if we're talking about things like sprites, well, then it's about the same weight as drawing any other sprite. Isn't how many times we're going to do it. More work if there's transparency. At some point we hit an upper bound. And unlike with the tile map of a level, we can't pre-bake them because they're going to move. They're going to each move in their own unique directions. But besides the fact that they do have a graphics cost, their behavior cost is very low. We are doing nothing more than adding a whole bunch of floats together every update frame and then checking to see if the time to live is expired. So, I don't have to call think functions. I don't have to call physics stuff. It's just draw on the screen and then, be done with it. In addition to the particles themselves, we're also going to need particle emitters. So how are they going to be created? So this is where entities can come into play. If we want something to exist over time, we could put a particle emitter into a entity. If it is a on-event thing like water splashing because you hop in the water, you can just momentarily create a whole bunch of particles, give them the color of the water spatter, the direction that they're moving in, and then let it go. And it will go do its thing and then go away. If we want something like fire coming out of a torch, then we can create an emitter that will exist over time. And then you can either model these emitters right within entities, make an entity emitter, or make it its own thing that entities might be able to have or attach to. Depending on the shape of the emitter, so we can have a point emitter where it's given a position in space and all particles emit out of it in some direction, or we can define it as a random but constrained, like a random position but constrained within the shape of a rectangle or a circle or any other kind of shape that we want. You can even get really fancy if you want to get like pixel perfect stuff and create like masks and where the particles should come out. But as with anything, you can go a bit crazy on stuff. I'm even going to make a very, very simple version of a particle system now. There are more complicated ones that you can come up with, and I would encourage you to figure out what features you would need for any game project you are working on, and try to see what would the requirements would be, and just program to that. Don't over-engineer it unless you have to. All right, let's jump into the code. So, here's our default game framework 2D. I rolled it back to the main branch with nothing in it, but what do I have in here? Make clean. Always make clean if you're switching around branches, which I have been. And then we have our GF2D. So we have nothing but the mouse and the background. All right, let's start designing what a particle system is going to be. Let's make a new file. I like my oldie include guards, if and def, particles, what particles? H, pound define, particles H, and if. This is the fun part, all the boilerplate code. Let's save this in my include in the right spot. And we're going to call this, I'm just going to call this particles. I'm not making this officially part of GF2D. I'd have a version of a particle emitter in my master branch, but I just looked that up for this video and it's showing its age and I'd rather redo it. Anyway. All right, so save this. So let's define what a particle needs to look like. So we're going to define the class, if this was C++, or in this case, the struct. So we're going to type def struct, and this is going to be a single particle. A single particle is at the very least going to have a in-use flag, a time to live. Let's call it time to live, and we'll just set it to 0 when it is no longer alive. So we should make this a float to work with better timing. Keep it as an integer space. I keep it integer space just for the sake of keeping it simple. But maybe I'll make it in TTL. So this is going to be my time to live in ticks/milliseconds. Milliseconds? I don't remember if it's 2 L's or 1 L. Doesn't matter. Spelling only matters as long as you're consistent. At least in programming. All right, now we need to know what kind of particle we're going to go with. So I'm going to make an enumeration of the different types. By the way, UN32 is not native C, just as a reminder. That's coming from STL. And I'm just going to go ahead and include my GFC types, which already includes that, and a bunch of other types that I would need as well. So I'm going to include GFC types.h. So now that'll exist. Now I want to type define an enumeration. No, wrong brackets. There we are. The type's going to be particle type. I'm going to go PT point. Particle type. The rect circle. Let's go with rect. And then PT sprite. Don't need a semicolon there. And then don't forget the comma there. PT max. So I can iterate through stuff and handle things. All right, now we're going to do our particle type here. Because I hate typing. Copy paste. P type. And now we're just going to start defining a whole bunch of things to describe the thing. Actually, I'm going to call this a shape, because do I have draw? And I have the ability to draw shapes, draw line, draw diamond. So So all the things that have already defined how to draw, I'm going to work off of. I even have polygons here. I've been busy. So instead of rect, I'm just going to call this shape. So we're going to need a vector 3D, which we're going to need to include vector GFC vector. Yeah, just vector. I'm also going to go ahead and add color, GFC color. .h. So vector 3D position. Vector 3D. Oh, I'm doing 3D. Sorry, I need to do 2D vectors. This is 2D space. Although, if you wanted to simulate like an isometric view on things, you could, in fact, or in theory, make it 3D and just adjust the vertical height based on its z height. If you're doing like an isometric view, and have some success doing a design like that. I'm going to keep mine flat though for this case of this tutorial. And not the vector velocity. And then vector 2D acceleration. So, now as far as physics is concerned, we have position with respect to time. This is just position. So this is position with respect to time. And this is position with respect to time squared. There's also, so the zeroth order derivative of position in time, first order derivative of position in time, third, and then we have after acceleration there's jerk, snap, crackle, pop, and then if I remember correctly, lock, stop, and drop. Although I think the last three are still being debated last I checked, but those are the proposed names for the nth derivatives of these things. Yes, math is involved. So this is our positional stuff. So we're going to update our position based on our velocity every update, and our acceleration, it will update our velocity every update. So that's how we will add this to this, add this to this. Now I'm going to do a color. So GFC, is this? No, it's just color, I think. Or did I do GFC color? I just did color. In hindsight, I wish I had prefixed it better. So color, color. But guess what? Color itself can be changed over time. So I'm going to add a color velocity. I can even add a color acceleration. And what could be neat, actually that's not a property of the particle. The particle needs color, velocity, acceleration. Cool. And now to support the things that we might need, I'm going to add a shape, and I'm going to add a sprite pointer sprite. So for these I'm going to need GFC shape.h, and then I'm going to need down here GF2D sprite.h. I can draw the sprite as well. Sprites are going to need as well a frame, which I like to do in float, because I can have fractional updates on the frame. And then float, frame, rate. And then last I'm going to have float frame end. So this will be the last frame of the animation. And then float, not float, int loops. And this is going to be if true, loop, else, stop on last frame. In this case, I'm also going to need to start frame start and frame end. So actually, this doesn't need to be float. This can be an int. Cool. That may be all I need. Yeah, that's probably all I need. I mean, in theory, I could also add. I can go crazy. I can have these things change based on all kinds of features. I can have rotations for the sprites and the shapes, although some of the shapes wouldn't make any sense. Like, it doesn't make sense to rotate a particle or a circle. And our shapes define an axis-aligned shape, so that would make sense. But the sprites could, in theory, rotate. But I'm not going to bother doing that right now. All right. Like with anything, we're going to need particle star, particle new. And this is just going to grab a brief, grab an empty particle. So I am hinting that I'm going to make this a global resource. That is one design choice that you could make, where all particles are owned by the system and there's one particle manager for everything. You could, in theory, make each particle manager its own thing. So you can make a particle system as a resource that could be managed by the system. For the sake of this tutorial, I'm just going to make it a one global manager, and all things will share the same particle pool. So we're going to need the particle system. So void particle manager init, and then we're going to uint32 particle max. How many particles are we going to have at upper bound? At brief sets up the manager, pre-allocates all particles. That way we're not going to be constantly, I mean, particles should live and die quickly, so I don't want to be asking I don't want to malloc and free more often than I have to. By making them all a pre-allocated array of particles, I can avoid that memory overhead. It's a bit more accounting under the hood, but oh well. No, I don't have a problem with that. Param particle max, the maximum number of particles that can exist at once. And this will automatically queue up the close on that. Particles don't need to be freed. Because, actually, no, particles don't need to be freed. If you think about it, they have a time to live anyway. So once they are created, I can just forget they exist. And they will be cleaned up on time. I'm going to make a void particle manager clear. And what this function is going to do would be called when I close a level. It's going to clear all particles, all active particles. So if I end the level, I don't want the particles from the last scene to be rendering in the next scene. So I'm going to just kill them all. So particle new, get back to particle stuff. Heck, you know what I could even probably do? I could probably parse a particle from a JSON if I really want to get fancy. But for now, I'm just going to hard code it for the sake of this tutorial. So let me just go make these functions real quick. Copy new, and now let's see, I'm going to pound include, I called it particles.h, this is my end of line at my end of file, paste, get rid of my comments, save this in my source folder, particles.c. Boom. All right, so we have the particle type defined. Now let's define the particle manager. And we're going to have a particle list. Is that how you spell particle? I've been staring at this word now for so long, I'm not even sure. I'm going to have to, like, check. Particle? I have to look it up. Yeah, it's particle. All right, good. I don't know why I thought. You've stared at a word long enough, and it stops to make any sense. particle list. And uint32 particle max. So how many we're going to have? This one's going to be pretty straightforward. So we're going to make this static, and so that this will not be accessible outside of this file. Particle manager, and we're going to initialize the whole thing to 0. And this thing's going to come along, and if not particle max, we're going to, oh, let's make sure we include this log. Pound include simple logger.h. So let's give ourselves some logging, simple logger. Cannot allocate 0 particles for the return. We are going to need something to clean this up when we're done, so void particle manager close. And what we're going to do is if particle manager dot particle list free particle list, and then we're going to memset the address of particle manager 0 size of particle manager. Cool. Just cleaning everything out, and then down here we're going to add exit that. Now what we're going to do is particle list equals GFC allocate array size of particle, and the count I want is particle max. If not, this slug the error, failed to allocate particle for the manager, return, and then what we're going to do is set our particle max equals our particle max. All right, cool. So we initialized and wiped the whole thing. Our particle new, oh, actually, no, it's really neat. All we have to do for this particle manager clear is a for loop. Oh, actually, no, all we need to do is memset that, right? So memset, all right, first of all, let's make sure we actually have a particle manager so this doesn't cause a crash. So if we have a particle list, actually if we don't have one, return, no need to go. Otherwise, memset the whole damn thing to 0 size of particle times particle max. So we will just wipe the whole list of particles back to 0 when we call the manager clear. But only if we actually have one, otherwise it doesn't do anything. All right, so for I equals 0, while I is less than particle manager particle max, I plus plus. And we're going to return null if we are all out of slots for new particles. Basic memory management. So if particle manager particle list sub I dot TTL equals 0, because we were unsigned 32-bit integer. Where is that? Unsigned 32-bit integer. If we're 0, then we're going to return this one sub I, but the address of that we're giving it back a pointer. So if this is 0, we won't iterate at all. It'll skip to the end. If we call this before we've initialized, nothing will happen. Actually, I do want to make one little thing. Particle sub I dot TTL, just in case this gets called like in bulk. I'm going to set it to 1, so it should at least exist within a current frame, and then it can be overridden by whoever the calling manager is. Can even default a bunch of stuff. Actually, what we should probably do is also memset the whole thing, because we should only at some point memset the address of this particle to 0, size of particle, then set the TTL to 1, just to make sure we get a clean particle every time. So C doesn't automatically initialize new variable. It doesn't mean we can't, because we know how often we're going to be doing this. Yeah. All right, now, as any resource manager, we're also going to need a particle draw. So void particle draw. I'm just going to have this one take a pointer to a particle. It's called P. So I don't have to type that much. If not my particle, return. And now we need to switch what our type is. So switch P-type. Switch is not a function, it's a system call, so I like to add a little space here. Case particle type max, and case particle type point. So default will be that. And then this is going to be, well, it's my draw stuff. Draw pixel. So here's what we're going to do. We're going to draw the pixel. Oh, look at that. We take a color. Draw pixel, color. What pixel are we drawing? What's the 2D vector that we're going to be doing? What's going to be P, color. And this is going to be the particle position. Well, that one is simple. What about the case of PT shape? Break. How are we going to draw that? Well, we have a draw shape, don't we? Like, we can just take whatever our current shape is and draw shape. Draw the shape with the color specified. One difference that we're going to need to do here is, oh, there's the offset. Neat. We can use the 2D offset to draw the shape. Remember, shapes, as I have written them, are meant to be off, the positions are meant to be offset from something, or the raw thing. So in this case, what I'm going to do is the, say, X and Y coordinates on the shape are going to be the offset from center. So whatever the center point is, the origin is of our thing, our shape, we're going to be drawing relative to that. In this case, the center is going to be the position of our object. So we're going to call draw shape. And the offset here is going to be P position. The color is going to be P color. And the shape is going to be P shape. And I also noticed that this is not a pointer. Cool, not a pointer. Don't have to worry about it. Finally, case PT sprite, I think was the last one we did. Just double checking here. Point shape sprite max. Okay. Now we need to draw sprite. And this is going to have whatever it is we did for the sprite. So let's go to, where's my draw sprite? Draw. Sprite render. One of these is a wraparound to the other. This one has flips and all that fun stuff. This one has flips. This has clip. This doesn't have clip. Yeah, let's make it simple. Most of these options are nullable. So yeah, they're all optional. So I'm going to null a lot of them out. So the sprite we're going to be drawing is the P sprite. the position we're going to be doing is P position. The scale, well, no, I'm not going to scale it. In theory, we could. The center, we're not going to worry about rotating or scaling, so all this can be null. The flip is going to be null. The color, now this is where we probably do want the color to be modified a bit. So what we can do is we can use the color that's associated with the sprite as the color mod. What that means is, if I haven't talked about it with you in one of these videos previously, when you're drawing stuff with SDL, it's like rendering things, and we get, let's see, it's like draw points. These base work on a renderer, and then the renderer, we can set draw color. This draw color ends up becoming, when I'm doing a sprite, an upper bound. So if the color was black, doesn't matter what the color mod, it's going to come out black, because that's where you have 0, 0, 0 for red, green, and blue. If I had a color that was white, but my color mod was just red, I'm going to filter out the blue and the green, and I'll be left with whatever's left over. So it's a filter on things. With that said, I have made a sample cloud sprite to work with this. It's translucent, but it's all in grayscale white. The idea being that I can use my color filter to shift this to any other given color. So a filter of 111 is going to draw exactly this, but then I could say filter with just blue, and this will draw as blue, or any color for that matter. So let me provide that. So I need the address of my particle color. And what frame? So that wants a uint32, but we have it in float, so we're going to cast it as a uint32, and this is going to be p frame. Okay, now we are going to need the ability to update said particles. Void particle update particle star p. If not, particle return. I mean, I don't even need to worry about the typeset, because all I'm doing here now is the update stuff. So what I'm going to do is, as I said in previously, we're just going to update all this stuff. So I'm just going to copy pasta. Okay, if, all right, so we're going to do TTL. For now, I'm just going to do minus minus. We're just going to tick it down. In theory, if you want to make this based on time, since I'm putting this in milliseconds, what I'm going to do is, well, I would have to treat it as milliseconds, so I'd have to get the time since the last update. And I don't remember if I exposed that ability, but let me take a look real quick on my graphics section. Get next frame. Get frames per second, set frame delay, but never actually got the difference between the frames. This is something I should probably do at some point, is get the difference between the frames, because if you take a look at my graphics next frame, what this is going to do is draw and then frame delay. The frame delay is going to get the difference between then and now, and I could probably just also keep track of the difference between then and now, and then provide that and use that difference between the last frame and the current frame to advance my time to live, or in this case, subtract from my time to live down to 0. But for now, I'll just make it based on frames, not milliseconds in frames. Okay. Now I'm not lying as much. Okay, so if not, cool, return, nothing else to do now. It's unsigned int, so subtracting from 0 should result in nothing, or does it loop? Let's find out. But now, paste. Nope, I wanted all this stuff. I need all these. So I need to add vector 2D, add, and the way I did it is position. The first parameter is what gets changed. So it's like writing out something equals something plus something. And we're going to do p position, so we're going to add to itself, and then p velocity. Cool. Don't need position anymore. Now I need to update velocity based on acceleration. We're going to do the same thing. Velocity, velocity, acceleration. Cool. That's now done. Now for color. I'm doing the same dang thing. So in this case, do I have color adding? Color copy. Here's something like, I always say, don't engineer something until you have to. And this might be something that I now need to have to. Get hue, set hue. Here it is, add. Okay, cool. I did actually provide this. Adds colors A and B and saves the result to destination. If this is null, results are saved here. The format for A is used for the resulting format. Conversion happens before adding. Cool. So what's neat about this is that I can represent my color as hue, saturation, and value. If I haven't gone over that real quick, hue is basically your color wheel from your red at the top to green at 120, and then blue, pure blue would be down around was that 240, and then back to 360 when 0 are the same thing. So there's your color wheel from red, green to blue, and then all the lies between red and blue. The saturation would then become how much grayscale your thing is going to be. So saturation between 0 and 1. 0 meaning completely grayscale, 1 meaning just the color. And then lightness, 0 is black, 1 is white, and 0.5 is the pure color. I also seem to recall I may have actually messed up the this comment. And then alpha value is the same. So how transparent versus opaque it's going to be. There are times where keeping a color in hue, saturation, and value until you need it to be red, green, and blue is very handy. And that'll come into play here. So let's go to my color add. Color add. Oh, I should have been able to just figure that one out. But it takes a pointer since we're modifying something, and it's a struct. So the thing that we're modifying is p color, needs a pointer to it. The thing, and then we're going to use the format of p color, and then the whatever color velocity we have here. And in theory, we can also now add the same thing into color velocity. And color acceleration. Cool. Now all these are done. What else did I have to update potentially? The frame stuff. So what's my frame rate, and if we loop or not. In fact, here we can even do it if p type equals p type sprite. No. So you only have to worry about this if it's p type sprite. And what we're going to do is p frame plus equals frame rate. Cool. That frame is done, and so is frame rate. Now we need to check to see if p frame is greater than or equal to frame end. And if so, now if loops, so let's just set this if it's greater than frame end. If loops, then we're going to say p frame equals p frame start. So we'll go back to the beginning. Else, if we're not looping, we're making it a single pass. P frame equals p frame end. And now we're just going to wipe out the frame rate. So p frame rate equals 0. So we'll no longer update this at all. All right, now that's how a particle is going to update. All right, void particle manager. So here's what's kind of neat about a particle system. Since all the particles are basically moving independent of each other and of the world, I don't need to care about doing them in lockstep. So with entities, I want everything to think first on the same state of the game world. And then I want to move everything, update its position a little bit at a time and where it's going to be. And then I will go through and I will draw all my entities. Particles don't need to have that distinction. So I'm just going to go ahead and make one loop, one pass through all of them. I'm going to do the same thing up here, but we're going to do particle manager, draw, or draw, just call it draw. Oh, I never made a count, never declared my eye. All right, that's done. And so we're going to go through each stinking particle. And now here we're going to do if TTL is greater than 0, so only update the ones that need to be updated. Then what we're going to do, I'm going to put this at the bottom, so I don't have to forward declare stuff. Then we're going to particle update. And the particle we're going to update is this one right here. But remember, doesn't take the particle, it takes a pointer to the memory on the particle. And after it has been updated, then we can draw. We can draw the particle. I need to add this one to our header file. And I'll say it in the comments here, at brief, update and draw all particles for the new frame. Isn't that fancy? All right, let's go to game. And we're going to add our particles.h right here. And we're going to, after we initialize sprites, since this works on sprites, order of initialization does matter. I'm going to, oh wait, actually there's one thing I do want to make sure I do in my, when I clear my entities out. Since I do have a pointer to a sprite, I do need to clean that up. So it's not a matter of clearing everything as well. So particle new. Before I mm set, I need to check to see if this one has a sprite, then gf2d sprite free dot sprite. So I can't actually do the clear all at once. I do have to go through them and iterate. It's important not to have memory leaks. And because I don't care, this way I'm keeping links to sprites around longer than they need to be. Either way. For I particle manager, if we have a sprite, I'm not even, since this is clearing everything out, I only check to see if we have a sprite, then we should free the sprite. And we shouldn't have to worry about the pointer living past this, because the very next thing we do is wipe out the whole structure to be 0. Same thing here. We set it to, we free the sprite, and then we set the thing to 0. This should make sure. Okay, so if we have particles that are made and then, yeah, this should clean up. All right. Anyway, I was trying to grab before I at least realized my bug there. Boom. And how many particles do I ever have at the same time? Well, these are lightweight, so I'm going to probably put a lot of them in here. So let me just do 10,000. There we are, 10,000 particles. And then, Now here's the thing where we need to figure out where we want to draw them though. If we're at a level, maybe we draw it as part of the level above entities, below entities, and then sometimes you might actually want to have to layer them in different places, which is why this structure might be oversimplified for whatever your purposes may be. Where's my update? Here's the draw. So where do I want this stuff to draw? UI elements last, draw background first. So I'm just going to do it right here. All right, let's see if this compiles. Make, ooh, good, typos. Now the debugging starts. If particle manager used, particles.c15 does not like that. Oh, that needs to be a star. No, that cleared up most of them. Article manager, yes, we don't want the article manager. Line 47. And acceleration I misspelled on line 80. 2 C's, 1 L. And loops, that's part of the P. 91 if P loops. Implicit declaration of draw pixel, of course. That was silly. How silly. We need to actually include our draw. gf2d draw.h. And particle draw. Doing the things a particle could draw. Did I mean particle draw? Yeah. Part to C. Okay, so that's line 141. Oh, didn't like. Wait, did I misspell the function particle draw? Part to C update. Here we are. Hey, all right, seaworthy. Let's see if it floats. Okay, nothing crashes. Nothing crashes. All right, now let's start putting this thing to the test. So now that we have particle, the ability to make particles, let's make a particle, a single event. I'm not going to make a emitter just yet. Let me just make a single void particle spray. And for this, I'm going to have uint32 count, how many particles I want, color, color variation, vector 2D direction, and then vector let's talk about spread. Let's call this float spread. So we're going to have a spray in a direction with a spread. And then the direction will be used also for its speed. Actually, let's do that separately. Float speed. Speed, we have spread, and we have color. All right, so this is going to int I particle star particle p. It's, as you can see, I have trouble spelling. For I equal 0 while I, you thought this was going to be a quick video, didn't you? Oh, it's particles, it's simple. How involved could it be? Yes, the answer is yes. I hope you like long form content. All right, so P equals particle new. All right, as soon as we're out of particles, no reason to keep going. We're going to be out of particles till the rest of this is done. Otherwise, let's start setting their color based on that. Let's see, so P color equals, actually I don't have to do that. I wrote a color copying Here we are. Destination, source. So we're copying into particle color the color from out there. We're going to have some variations. So whatever that variation is going to be, I'm assuming these are the same format here. So let's set p color dot r plus equals crandom, or was it GFC crandom, which gives me values between 1 and -1 in floating point, times variation dot red. Do the same thing for all of them. If this happens to be hue, saturation, value, then that's just what these will end up being. The red is the hue, the green is the saturation, the blue is the value. And let's even do the alpha as well. I should just, why did I type that out? That's what copying is for. Alpha. So maybe I want some, what do I do? Maybe I want something a little bit more or less translucent. So if I want the to vary 0, I just make this completely 0. Now I need to set my direction. Before I do any of that, let me vector 2D. No, is it just vector? No, what's my normalize function? I always forget. Find normalize. Normalize taking a pointer. Yeah, that's what I want to do. I want to change the vector. Now this works because my vector type is a struct, not an array. So I'm getting a copy of the vector. I'm not getting the same vector that was passed. If it was an array type, then I would have gotten it as the original, and this would modify the original, which I would not want to do. But in this case, I don't care. So I'm normalize the direction, use the pointer to it, and then probably could have a speed variation. For now, I'm just going to, no, this is fine. So what I'm going to do is the spread I'm going to use to rotate my vector here. So I believe I have a rotate function. Vector 2D rotate an angle in radians. So it doesn't matter. Just keep in mind that when I call that, the spread is in radians. So I'm going to rotate this. Let me make another vector here, so it's not the one. Vector 2D. D. And this returns. Cool. So I'm going to rotate dir by GFC crandom times my spread. So a 0 spread will make this a 0 change. So this should be unchanged. I'm going to set D equal to this. After that, now I'm going to vector 2D scale. Yep, that's it. Vector 2D scale, destination source factor. D speed. In theory, speed could have variation. I'm just kind of skipping that now for the sake of calling this done. And now I need a time to live. So one of the things I'm going to add in here is 32, time to live. How long do I want my particle to live? Anything else that I think I need to make my particle work? Let us see. Oh, the graphics, what it's going to be. Oh, this one's just going to be a spray. So I'm going to leave my type being 0, which is point. Yeah, I'll leave it at that. All right, make sure, check my code. Cool. Let's expose the function to things. Excuse me. spray of particles from, oh, I never actually gave a position. From position in direction. Not position count. So let me go and fix that now. I need vector 2D position. So vector 2D copy. I think this is a macro, so I can just pass my name here. Or is it CPY? It's copy, okay. Copy into P position. Oh, and this is actually going into P velocity. And yeah, right. The rotated direction, scale to speed, saved into velocity. Good. But we need to copy the position and the position. All right. So this needs to be what we have in the header file with our forward declaration. Now, this is the point where I have so many parameters, I will new line them like so. If you follow some other videos, I generally prefer one line, but when it gets this large, I will do this to make it more easy to read. How many particles to spawn at param? Actually, I think I do want the speed variation, otherwise it's going to be like a wall of particles moving all together. Speed variation. Let's make that a capital V. It just keeps getting more complicated. And then this is going to be speed times GFC random times speed variation. Whole lot of random. All right, TTL, how many frames each particle should live at param position, where to spawn from at param. Color, what base color to make the particles. Variation, how much that color should vary. Direction of spray. How fast the particles should move. How much the speed of particles should vary. How much the direction should vary in radians. Okay. Let's see it in action. Now what I want to do is if SDL get mouse state. So what I'm doing here is whenever I press the mouse, I now have the X and Y position of my mouse. And now I'm going to call this. So whenever I click the mouse button, I'm going to create a spray. How many particles I want? Say 100 to start. Time to live, how many frames? 30 frames, so it'll last, I think, about 30 frames a second, so it should last a whole second. The position, vector 2D, is going to be made from mx and my. the color, GFC, I'm going to just give it a default color, blue, make it a water spray. The amount of variation, actually let me do, instead of using one of my prefabs, which I believe I use 8-bit as the format, GFC color HSL, hue, saturation, and lightness. It's very similar to hue, saturation, value. It's just the last, different how the last thing works. So the hue, let's make it blue, which I said should be around the 240 range. The saturation I want to be 1, and the lightness, let's make it 0.0. Keep on trying to capitalize 0.5. And now the variation on that, also I'm going to keep in the same form. Oh, and the alpha value I'll need. So I want it to be 0.9, mostly solid. Now the variation, how much do I want the color hue to vary? Let's go with plus or minus 10 degrees. The saturation, we can go plus or minus 0.1, which, when I think about it, did I do that right? I don't want to have a negative. Oh, I know what that's going to do. And how this is going to vary 0.1. Actually, I'm just going to leave that one alone. I don't know what that would do. And how much should my transparency vary? Let's do it that way. Now the direction. I don't know what direction to do. Maybe toward the center. So, or toward, I don't know, just do it up. Vector 2D, 0, -1. So it's going to always shoot up. How fast we're going to move, let's do 2.5. Speed variation 0.2. Spread, now this is in radians, so pi would be 180. Half pi is 1 point something. Let's do 0.5 as the amount of variation. And let's see what happens. Make. All right, moment of truth. Oh, I see a single pixel point showing up. All right, it's very possible that this isn't nearly enough to see it. Let's make them last a bit longer. And make sure my particles are... My position is copied. Yes, I saw the position and it seemed to be in the right direction. My color variance, it showed up. It was a blue pixel. So color, the velocity, my velocity is this direction. Well, let's see what happens. Well, you know, this is when we start slogging information. Oh, I never said the TTL. That's why it's only 1, because it's only showing up 1. PTTL equals TTL. Even that should probably vary a bit. Look at that. My variation is... That's kind of neat. I like it. I like it a lot. All right, let me see what we can do to improve this just a little bit. For one, I don't like it that it seems to be going vertical up and down. That may be amount of my rotation spread random times. Let me first see if I can just turn that off or dial it way down. I guess at 0.5 radians is probably a lot. Let me shrink that down a bit. Though I don't know why. Oh, is my velocity going negative? Yes, my velocity is probably going negative. Where did I assign that? My speed times a negative plus. Or what I could, yeah, or what I could, times random and not get a negative value. Now I actually do want to make that spread higher. Interesting. Oh, wait. That one should be random. That one should not be random. See, random gives me 0, or -1 to +1. Random gives me from 0 to 1. There we go. Now I can tighten that up a bit more. 0.25, cut that in half. Cool. Let's add an acceleration. Speed bed, and then let's go with vector 2D acceleration. Now let's go vector. We just have to copy. All we're doing is that is copying. Oh, right. Now I need to add this to my list. Go to back to particle spray. Oh no, let's go back to here. And now we're going to add another vector here, vector 2D. And this is going to be my acceleration. So I'm going to give it a 0, horizontal acceleration. But let me give it a positive 0.1 vertical acceleration. Oop, that's a bit much. 01. Nope, didn't compile yet. And let me really lower this, and then really increase this. Where's my initial velocity? And I need to have them moving a lot faster. That's 2.5. Let me double it. Let me just make it 5. And there's my particles. Moving. I really hope that this actually shows up, given the resolution that this video is recording at. Let me do one last thing. Let me really change my colors, my color variation, and see how that works. Oh yeah. You know, making all kinds of colors. But notice how they stay anchored toward the blue. That's one of the benefits of varying the hue rather than varying red, green, and blue. Because generally when you vary red, green, and blue by some random factor, you end up getting like a whole bunch of browns. And I can change the base color to say red. There we go. Now I'm kind of going a little bit into the orange. Probably even a little bit of purples in there too. So if I actually lean this a little bit to the right, say 10, and vary this by 40, we should stay mostly red, but lean a little bit to the yellow side of things. And now look, it's a volcano and it's erupting. Oh, run away, people. All right, one last thing before I end this video. Let me just see what the sprite would look like. So, what I'm do is I'm going to load this sprite that I saved into as cloud PNG, which I stored in images effects cloud. So I'm going to set my particle p type equals to particle type sprite. Now this one's going to have, I need to define p loops, that should be say 0. Frame rate doesn't matter because there's only one frame. So start frame and end frame are both 0. It's going to, the frame rate's going to be 0. It's not going to do anything. It's just going to stay. None of the animation stuff should kick in that I did down here. Since this is going to stay 0, is 0 greater than, it's not going to do any of this. It's just going to skip all that. But I'm going to set my sprite equal to my sprite load. Load all. Okay. And my file name is going to be images effects cloud.png, frame width and height. I believe I set that to be 16 by 16. I did. Frames per line, 1, keep surface, no. And there we go. Now this is probably going to start. It's probably going to start really lagging with that many things to draw, since I set the limit to be 100,000. Actually, let me turn my frame rate rendering at how many frames per second. This may impact it. So we're hovering around 62. Oh wow, this is handling it no problem. That's probably more of a testament to the laptop that I'm running this on. It has a pretty good graphics card and not the efficiency of what's going on. You can see the color variations rather nicely. Let me even just, this is just so much fun. I'm going to also change the hue saturation. Let me change my, oh, this is color variance. See, the other thing I could do is color acceleration, which is what I did in the other one. I'll just hard code it for this example. P color velocity equals GFC color hue saturation lightness, and I want my color velocity. So this is going to be how much my hue is going to change over time. I actually don't want it to change over time. My saturation, I do want it to go down. Let's make that a negative number. And my lightness, what did I say in my content? Here. Lightness, 0 is black, 1 is white. So let's make it go darker too over time. So negative 0.01. And then I'm going to do the same thing, negative 0.001. And that is so it should go transparent over time as well. Let's see. Oh, that's neat. Not what I was expecting, but still neat. I think it just keeps, I think it loops, and that's probably not what I wanted to do. Oh well, it was a thought. Anyway, have fun with this. I look forward to seeing what kind of projects people can come up with adding a particle system to it. I'm going to add this to the git status, git add images effects star, git add include particles, git add source particles, git commit, and this is going to be the particle tutorial code base. Cool. Now the code is also in the cloud in the particle tutorial branch. All right, thanks for watching. Have fun.